Hi, Mr. Dean. I hope you and your family are doing very well during these times. I hope you're in good health. But most of all, I hope you enjoy our presentation on our automatic whiteboard eraser made by me, Cole Swartz, Caleb Floria, and Alex Lawrence. So the problem we found was that whiteboards can be a hassle to erase. If you write a lot, especially large amounts of notes on your board, it can be a hassle to erase all of them, and it can be a waste of time when you're erasing your board instead of teaching. If you're too short or maybe have back issues or shoulder issues, arm issues, anything of the sort, it can also be painful and more of a hassle to erase your board. We aimed to make a product that would not only make erasing your board more efficient so you could spend more time learning rather than erasing your board, but also one that would decrease the burden on teachers or people using a whiteboard so that it can be more efficient and they can be more efficient. So justifying our solution and the issue itself, my team made a survey of the high school teachers at Prattville Christian Academy and asked various questions. These big three are the main questions that we asked that help justify our solution. The first one, how often do you use your whiteboard? 87% of the responses said that they do use their whiteboard often. So there are people who use their whiteboard, there are people who could benefit from our product. When you use your whiteboard, do you have trouble erasing it? A majority said that they did have trouble, so obviously our product is helping solve this issue, or will help solve this issue, sorry about that. Would you use an automatic whiteboard eraser if there was one available? The large majority, 87%, said that they would, so there are people who would be willing to get this product if it was available. So obviously our main market would be intended for schools, perhaps primary and elementary schools, because those younger grades are the teachers of these younger grades often use their whiteboards more than high school students, or not high school students, but high school teachers. Many high school teachers are moving more towards smart boards and more advanced whiteboards, projectors, and the such, especially college professors use projectors and smart boards. So we're mainly targeting these primary schools, elementary schools, where the children are taught through their whiteboards, or teachers who just prefer to write on their whiteboards. I know a plethora of teachers at our school who prefer this. Coach Staggs, Miss Stow, and Coach Laverne, they all prefer to write on a whiteboard instead of using a projector. So our main goal was to create a product that maximizes the efficiency, keeps students engaged, and minimizes time wasting while teaching. And obviously this product has to be accessible and affordable to these people so that they can get the most use out of the product and we can actually solve this issue of wasting time in the classroom and putting burdens on teachers. So there have been previous attempts as shown on the screen in this video. But this previous attempt was very clunky, it looks heavy, it looks complex, mainly, is the issue. It's got two large motors that pull it side to side while also having motors that push it up and down. It does a great job of erasing, however. It just looks slow, heavy, clunky, and cumbersome, like I've said before. So we wanted our design to be more efficient, quicker, and more elegant, something that wasn't going to be so abrasive and obtrusive, so it wouldn't be a distraction. It'd be something in the background that would quickly erase without anybody noticing it, so you can improve the student engagement and increase the amount of time spent learning. So the design process. We went through a plethora of designs. We thought of like a windshield wiper that would go across the board, and we thought of other designs, but what we really focused in on was this design of a single plank that would move across the board horizontally, erasing it, very similar to the previous attempt. Just, it seemed to be the most simplistic, the least complex, that just seemed the most efficient. Now, for our design, we wanted to minimize the number of motors, so we really wanted only two motors, one at the top and one at the bottom, so that the board would move smoothly across the board. As you saw in the first attempt, the bottom kind of dragged behind as it moved to the left. However, for our board, we wanted it to go smoothly straight across, applying even pressure so that it could erase in one or two passes quickly. However, the biggest issue with our initial wheel and track assembly design was that we couldn't quite make it work with the parts that we had. Our original design had our track, this black U piece, resting on top of the whiteboard, mounted through the side to the wall, with the wheel sitting inside of it and the motor hanging off to the side, and using the motor as the main attachment between the plank with the erasers and the wheel itself. However, this didn't quite work out, and because our track system, our track piece that we had holes on the bottom that were pre-made, and it would be a really big hassle to have to drill into the sides. So it was just a waste of time, and we didn't want to, put in extra effort that wasn't going to get us anywhere. So we really had to rethink this whole design. Another issue was that connecting the motor to the plank in the way shown on screen wasn't really possible for us. There was no way to mount it with the materials that we had, so we really had to rethink this, and it took us the longest time to figure out how to set up this system and make it really work. However, we did find a good design that worked, and it looks really complex compared to what it originally was. However, it really isn't as complex as it seems. So our track system, our track itself, was mounted using the holes that were pre-drilled on the bottom. This saved a lot of time and just made sense. However, working the wheels and motors took some time to fit in there, and we came up with a design with the wheels sitting in there horizontally with the motor on top. Thankfully, our motor had these two screw holes to the right that really made it easy to find this L bracket and find like a good way to connect the main plank to that motor. So what's holding everything together is the actual drive shaft itself from the motor to the wheels. That's what's holding everything together, and that just came together really quite greatly that it was there. We didn't have to find any extra bracing or create some new type of brace. We could just use the drive shaft itself to rest everything on. However, this is not perfect. This was our first time doing it, and there are some flaws. This L piece, this metal L brace connector, was very flimsy at first, and due to the weight of the wooden plank and the erasers, it would bend, so we had to double it up, as well as we had issues with the wheels fitting into the track. It required a special set of wheels, and those wheels needed a certain amount of traction, which we aimed to create with like a rubberized material such as maybe electrical tape around the outside that would give it traction to stay in and really drive along the board smoothly. And off to our far right is just a picture of the main design. We did not have any pictures, so I had to draw all of these myself from memory. There might be some small corrections that needed to be made, maybe in scale wise, but this is pretty accurate to what we actually had. The whole project's pretty much ingrained in my memory now because we've been doing it for so long. I know this thing up and down. I could draw this in my sleep practically. And if you didn't get a good view, here is the whole system itself expanded. We've got the two motors on the ends connected to the main plank that will house the erasers, and also the cortex and our battery pack. So next, Caleb will talk about the construction phase, and Alex will talk about the coding phase.
Construction. Our construction process was to make an arm that would be lined with erasers and placed on a track system to clean the board. Some issues we face are having a lack of materials and tools. We face a problem of not having the proper wheels needed to run along the track. We also face a problem of not having the proper tracks to be able to hold our wheels. For our building process, first we took the measurements of the board to find out how long the arm needed to be to place the erasers to cover the whole whiteboard, and to find the length of the board for our track system. We then got our arm and hot glued erasers down on the arm. For mobility, we took metal pieces and attached them to the top and bottom of the arm. We then bent the metal pieces. From there, we screwed a motor connected to both metal pieces and added our wheels to the motor. For our track system, we got four metal bars that our wheels would fit into and screwed two of the metal bars into the top and two into the bottom of the wall. That would span the length of the board.
Hi, I'm Alex Lawrence, and I'll be explaining the coding process for the automatic whiteboard eraser. We programmed using the Robot C framework with the corresponding Vex robotic parts. The Robot C programs allows us to set the speed of the motors from the minimum to the maximum, and with a separate line of code, we can set a timer for that command to run. And once that timer runs out, we set the speed back to 0 to stop the motors. We measured that at max speed, it would take between 8 and 11 seconds to pass over the entire board, and we plan to go with 9 seconds to leave only the very edges of the board unwiped, to both make sure we covered as much board as possible without running off of the tracks. The VEX parts also include a Bluetooth controller, which with a separate line of code can be used to activate the code from a distance instead of a button that's been attached to the frame and hooked into the cortex. So this both reduces weight, material cost, with only a small amount of work having to go into actually coding it together.
So now that you've learned about the design, how we built our prototype, and the coding that makes it work, let's see how everything comes together. So simply, at the press of a button on our Bluetooth controller that's paired to the VEX Cortex, the motors would start to move and the whole assembly itself would run across the board, erasing it as it goes. Now, this is just an animation that I had to make because we have no video of it actually moving, but this animation portrays how it's intended to move across the board. Now, our goal was to get it to fully erase in one pass across the board, and the pass coming back to its original starting position, and we aimed for the movement from one side of the board to the next and back to its starting position to take under 30 seconds to make it as quick and efficient as possible, so it wasn't wasting any more time than you would manually erasing the board. Now, our design was definitely not perfect. It was our first time building an automatic whiteboard eraser, and it was our first time building just a complex system and product in general. So there were definitely areas that we weren't prepared for and that definitely could need some reworking. Now, these first two improvements came from the survey of the high school teachers that I showed you in the first few slides. We asked the teachers what extras or add-ons they'd like to see on an automatic whiteboard eraser if they were to use it as a product. And so this is what they had to say. The first is a system that would allow you to replace and take out the erasers if they need to be cleaned, or like I said, replaced if they're just old or something. This is definitely necessary to making sure our whiteboard eraser is the best at erasing as it can be, so it's the most efficient as it can be. And second, they would want a mechanism that could spray cleaning fluid on the board as the eraser moves, so it can once again be better at erasing. So these next two improvements are design-wise. We had some serious areas that needed reworking. This first one was finding stronger motors and making the product itself more lightweight. The weight was a huge issue for us. Like I said in the discussion of the design, that single L bracket that was connecting the motors and wheels to the main plank would bend under the weight, so we had to double that up. Furthermore, the wheels themselves, because they were mounted horizontally, would fall out of the track because of the weight. So finding lightweight materials that weren't just the metal or the just solid wood that we used would be imperative to making just something that worked better than ours, that was more efficient and could move across the board with as least difficulty as possible. And another thing was the stronger motors. Our motors, maybe it was just due to the weight, but the motors kind of lagged a bit, and they had kind of struggled to push the eraser across the board. And when our goal is to be as efficient and as quick as possible about erasing, we need strong motors that will get the job done and as efficiently as possible. This next improvement would be to rework the track and wheel assembly. As I discussed in our discussion of the design, the wheel and track assemblies were the biggest issue we had, and the solution we came up was definitely not a perfect solution. It had a lot of flaws in it. First of all, although mounting the track by the holes on the bottom so it would face out horizontally was the most efficient for us at the time, it definitely wasn't the best solution because, like I said, the wheels would fall out of the track. And having the wheels and the track assembly vertically resting on top of the whiteboard would definitely help keep it attached to the board at all times. However, that just wasn't possible for us with the materials we have. So reworking that connection is imperative, as well as, improving the wheels themselves. The wheels we had didn't weren't made for that track, and they needed a proper amount of traction that we had to quick fix with electrical tape. So finding a wheel that really fit, that was meant for the track and got the most traction as possible, would be imperative and necessary to making the most efficient and smoothly moving eraser that we can. And so finally, here are just the lessons learned from our time on this project. There are a lot of pieces of knowledge that we learned from this about procrastination, hard work, taking things seriously. But this is definitely the biggest one out of all of them, was to not rush the design process. This is something that applies on whatever products, or not products, but projects we work on in the future, is do not rush this design phase. We need to consider all possibilities and all variables in our designs or any plans, or like however we're going to organize our project. We need to think this through. This is something that we didn't do as best as we could have. First off, we didn't take a lot of time brainstorming. Once we found that design of the single plank of wood with the erasers that moved across the board horizontally, it just clicked, and I guess we did kind of shut down any other possibilities, and maybe that limited us. But once we got that one design, we just went with it, and we kind of just rushed into building it without properly thinking through the other things necessary. When considering a design, it's not only about the product and how you plan things to work out. It's about the materials and tools available. Those are the two things that we really overlooked. As I said before, the materials we used were way too heavy, and that caused problems for us. If we had taken the time to think of what lightweight alternatives we had available, what just materials in general we could get our hands on to maximize the potential of our eraser, if we had taken the time to think those things through, our product would be a lot more successful, and it would have been a lot easier process building it. Like I said, another thing is the tools itself. We needed to take the time to look at the tools we had to use, and we needed to take the time to find the ins and outs of these tools so that we could use them correctly. There were a lot of times that we were going to build something but didn't know how, or the tools that we have, we didn't know how to correctly use them, or we had to ask help to find like how the best way to use this and what we needed to do so we didn't break something. And thank you, Mr. Dean, for helping us along the way to make sure we didn't screw anything up, especially when you let us do something as dangerous as like drilling into your walls of your classroom. So that guidance really helped us in making our eraser successful. But so taking these steps and really thinking about your design, they play a large role in the overall success of your product. Like I said, many issues that our team faced could have been addressed early on, or even avoided entirely, if we had taken the extra time necessary to create a well thought out and planned design. So that's something that we can take with us across any projects we find now, or we find ourselves in the future, especially with college or work or wherever we're at. Anyways, though, I hope you enjoy our presentation on our EDD project, our automatic whiteboard eraser. Thank you for listening.